Well, hi, good morning. Thank you so much for joining me in my shop here. Today is February 16th. There's about 15 centimeters of snow on the ground and another 5 coming, I believe, today. And I may not be posting videos for a couple of days after today. I'm going to have some company here at my house, so I may not get in the shop here. So, end of the last video, capacitor showed itself to be scratchy once again, so I think I'm going to start by trying to solve what's going on with this capacitor. Before I turn it on, let's just take a look at it. See what we can see here. So it seemed to be scratchy, of course, when you get it mostly closed. Looks a little tight in here. I don't see anything really obvious. Okay, let's operate the radio and listen to the scratch, the scratchiness. Now I have it connected to an antenna, but the antenna is not switched on. So I'm not sure we're going to pick anything up in it, nor should it matter. I'm still up on the shortwave band here, I think. Yep. Let's just hear that. Here we are. There's that other sound. So that sound can easily be a resistor. That can come from a tube. Probably from a capacitor. Probably from a poor connection, like where the tube pins or something of that sort, or the band switch or volume control. And probably another 2 more things I can't think of right now. Seems to have quieted down a bit. A little bit pronounced during the warm-up. Interesting little experiment here. So I am ungrounded. I am a piece of semiconductor floating in space here, and I've picked up this signal, and if I get it close to the tube here, you can hear it, what the signal in me. What if I ground myself? So suppose I touch the chassis here. Let me put my finger right on the tube. Isn't that an interesting demonstration? Okay. Let's make this thing crackle now. That's very strange. That's what the antenna turned off. Okay, crackle. There it is. Very sensitive. Wow. I'm going to spot that. I think it's this side. So the stator plates here are pretty fixed in place. They're not too likely to generate it. And they're not going to get bent. It's these plates that get out of place. This outside plate seems to be the most, this one here. Oh, what was that? So I'm going to turn the capacitor, find another spot. Whoa, whoa, whoa. Holy smokes. Wasn't that bad, was it? That's got to be easy to spot. Supposed to be easy to spot. Let's try switching cameras here. I'm going to take a moment and freeze the focus on this camera also. You just bear with me a moment. Otherwise the autofocus is going to drive us nuts. Here, let's put it about like that. Okay. See that outside one? Looks close. This outside one here. Bend it out. So let's do one at a time here. I may have got it.
This month, you're going to hear every word.
Self-declared spokesman for God. Oh. I should have done this. Well, that seems to have gotten it. I'm going to bend these out just a little bit here too, only because they just look comfortably tight. One more try. Good. That was easy. Easier than expected. What a good workout on the dial and the string and all that too. Okay, we're going to start the alignment process on band number 3. And if we look up here, we see... Listen to that. Boy, oh boy, how am I going to sort out what is causing that noise? Wow. Cut the radio right off there. Let's try this. The radio's off. We're going to pop this middle tube out here, the IF amplifier tube. Oh yeah, that's right. We'll bend it towards the... You can't. Okay, power back on. With this tube out, this whole front end of the radio can no longer be heard. See if we still hear that sound. Still hear it. Interesting. Well, we could do the same with the detector tube here. nicely. Here, power on again. Pretty quiet now. That's pretty quiet. This is a 7B6. 7C. I don't have a 7B6 sitting right here right now. Okay, we're going to put this tube back in and listen to it as it warms up. Well, that tells us something. Okay. 7B6. That's what that was, right? 7B6. Let me just peek here at the schematic briefly, just to be sure. 7B7. 7B7. That's probably what that is. No, this is 7B7 here. 7B. Right. That's really 7B6. Yeah, 7B6. Okay. I have the feeling I don't have one of those. I think I had a hard time trying to find one last time. So it could be this tube that's making that sound. I'm going to stop for a few minutes and ponder my next move here. 7B6. Okay, so I've looked at the measurement here the next one is 12 megacycles. 12, and so we're going out 6.5 inches plus 2 3/8. That's 2 and just under a half. 2 just under a half. We give you 8. Just 8 and just under a half. 8 inches. 8 3/8. What am I saying? Quite easy. Okay, let's measure this up. 8 3/8. 3/8. Just under a half. Okay, so that's 8 inches 3/8. Right. Okay, so we'll tune the radio to that spot. There we are. Why am I using this? Because, I have this and I never get a chance to use it. So this is why I'm using this. Because I could just do this, couldn't I? Yes, I could. Oh, it's a double checking thing. Excellent. So we're tuned to 12, and we need 12 over here. Okay, we'll take a look at the instructions here. Okay, so 400 ohm resistor, 12 megacycles. Just for maximum image should be heard when tuned down. 900. And which thing are we adjusting? We are adjusting shortwave 3. Oscillator adjustment is down here. Okay, power on. Now, do we get the same crackling? Hard to say. Nothing from the antenna. Oh, we shouldn't be on the antenna. We should be on the signal generator. Okay, so it's a moderate signal. Radio should pick it up. Don't hear anything. What is the radio really tuned to? I didn't change the band. Now that's interesting. I flipped it to phono. We can still hear it. How interesting is that? It's just another indication that it's coming late in the radio. Okay, now we're on the right band. 12. A little out. Okay, so if we're picking it up at 12.6, and we should look for the image at 11.7. There it is. Okay, so this is the real guy. Where'd it go? And we want to move him down. Which way to return? I don't remember this noise when I started. What was that sound? Am I turning this already? I don't think I was. The screws are off center here. There it goes. There she is. Way down. Where'd it go? Wow, I'm way down there already. Okay, we'll go right to 12. Nothing like vintage equipment. Just wants to hop around. There we are. That's good. That's good. What happened to it? What happened there? What just happened? Things got way better. What happened there? Like the static went way down. The signal stayed up, I think. It got a funny sound to it. Okay, not funny enough to make me laugh. Now, what are we doing next? So we have this set, so 12 is at 12. The next step is same as step 2, 12, 3, 12, maximum. And this is the aerial adjustment. It was so sharp, surprisingly sharp on the last band. 3 aerial. It's pointing at the last hole. Is it really the last hole? It just pulls up. Yes, the last hole. Watching this meter and I wasn't. Last hole. Oops. There we go. That's that band. Now, next band, next band, next band. We go shortwave 2, 9 megahertz. Shortwave 2. Shortwave 2. Get that right. 9 megahertz. And the dimensions for the 9 megahertz is here. This one. Just under 6 inches. So we go 2 3/8. It's more like 2, and this is a 16th here they're showing. So we would do 2 plus 6. 6 3/8 minus a wee bit. 6 3/8 minus a wee bit. I will use the ruler. 6 3/8. No. 8 3/8 minus a little bit. 8 3/8 minus a little bit. Well, that's virtually where it is. That is correct, yes. 8 3/8. Oops. And then we want to go minus a little bit. There we are. Okay. This is for 9 megahertz. Can't quite get there. Megahertz. And it's changed. Way high again. .5, and the oscillator is where? 9.5. What am I saying 9.5 for? 9, and we are adjusting shortwave 2 oscillator, third one down, third one. This way. The further you get into an alignment, the more important it is to not make a mistake and undo some goodness somewhere. I don't know if you noticed that very interesting effect. I'll have to tell you what it is in a moment. There, that effect? Does it sound like a microphone? Interesting. We can't get much closer than that. Oh, that's 9.5 though. That's no good. That's no good, Chip. Go down. Okay, we're going to try to find it. Wow, almost booped it there. You can hear it already. Oh, I haven't moved this much. Okay, that's the way. Go quite a distance. Where did we get to? We practically there. Okay, set this right on. game, you know, how precise can you turn these guys? Sounds like feedback in there. Very good. Next one must be the antenna adjustment. So if we just work back here, aerial adjustment. Oh, it's here now on the side. Second one from the end is the aerial adjustment. This one here. Straight up. Oh, this is loose. Okay, that was just about where it was, I think. Okay, we're on our way to the next band. The next band is 6 megacycles. Which way to turn the knob? Four, three, two, one. Okay, and we're doing this at 6. We're around 6, and the measurement for 6. The measurement for 6 is. We gotta go. Oh, we gotta go back. So now we're looking at 6.5, 8.5. 8.5, 1/8 short of 9. 1/8 short of 9. One-eighth short of 9. This should be 6. Should be hearing this. If I get it to 6. High again. Okay, now which one are we turning this time? We are moving 6. Oscillator 4 from either end. 4 from either end. And we want to move it in the direction that increases the stick. Tight. It's just about as tight as it's going to go. That's all it's got. Something going wrong there? Why? So it's right at the limit of the trimmer. Right at the limit of the trimmer. So what would go wrong? We would have measured it wrong. Let's double check all this. Make sure, because we're looking at 6.5 inches plus 2 3/8. So it's 6.5, 2.5 less than 8. 6.5 plus 2 is 8.5 plus a half is just under 9. So it's just under 9. I got it right. Just under 9. That beat it. I can't make it any more accurate than that. I can't turn the adjustment any further. And I'm not about to start bending plates out and doing all that stuff, because I think that sounds like a scary process. Cranking it down, I'm trying to get more capacitance on the trimmer. Can't do it. You can't bend these plates out and get more capacitance. You get even less. So that's it for that, except tune it in. And then let's do the last adjustment, which is going to be the antenna. Shortwave 1 aerial last hole on the line here. Oh, I hope my stomach doesn't come over the only one of those sounds were in my stomach. Very good. Okay, so that's it for the shortwave bands. What's left now is the broadcast bands. And oh, what's this? Wait a minute. Wait, I didn't do this. Step 10. Loosen trimmer half turned from tight position. Series. This is the broadcast. This is the broadcast. I've jumped ahead. They didn't put it here, but step 10. This is actually a broadcast. They didn't put BC here. Why not? Why didn't they do that? Loosen the trimmer half a turn from tight position. Maybe that's where you start. Loosen trimmer half a turn. Do you come back to it? Yeah, you come back to it down here. Adjust for maximum. So again, these things are often written as if the radio has never been aligned. If it's already aligned, everything is close. Should be close. I'm not so sure I really want to do this. But obviously what they're saying is you're fixing the position of this one, and then these ones are being adjusted against it. But then you're making a final adjustment here. You can always check and see how close this is to tight. Okay. And where are we on the clock here? I'm going to stop for a little bit. I may stop completely here today. I've got lots of stuff to do outside of my shop here. Yeah, let me stop for a couple minutes. Okay, so I've got this adjusted now for 1520 in the broadcast band. There we are. Okay, I'm on broadcast now. 1520. I measured it up. I've got this set to 15. Here comes my favorite interference. The woodpecker. I have my own woodpecker here. How bizarre. So this noise haunts me almost every morning at some point. I have no idea what it is. Okay, not to lament about that. We just carry on and try to ignore it. So we're tuned to 1520. We're not hearing 1520, so let's hear what this is really tuned to. Okay, the adjustment is, the shunt adjustment is first at the back. Ah, went away. First at the back. That was a really good example of that interference coming and going. It's a static, I thought maybe it's a static electricity discharge on something, somewhere. That doesn't make a lot of sense either. Okay, Which way? Wow, that was kind of scary. You got me. Don't know. This is just too flexible. I'm going to use a bigger screwdriver on it. There we are. Okay. Now. Sticky, that's what the problem was. We're at 1520. 1520. Checking the tuning. Yeah, we're like a needle width. Very good. Okay, that's that one. Of course, we can't tell if it's actually correct because we're just going by the measurement. Turn it down a bit here. Next step is done at 580. And we are adjusting the series trimmer. Wait a minute, no, I missed this one, didn't I? Broadcast aerial, I missed this. Broadcast aerial, we just do it where we are. 1520, yeah, don't miss that. Broadcast aerial. Again, this probably should be done with the final antenna sitting there on it, not the signal generator. That's why it's telling you to pad it with resistor and capacitor, stuff like that. Oops. Come on. There we go. Okay, maximum. Watching the meter now. It's a big screwdriver in a small hole. Screwdriver too big. Go. And the last thing is to adjust this series one on the back. Now that's done down at 560 or whatever it was. What was it? Was it 560? 580. So we'll go down to 580 and we'll check it anyway. 580. Did they not put it on here? 580. Oh, that's what this line is. The one they didn't name this line. They just put it here. Oh, you crazy draftsperson, you. So this one's lining up here. That would be 3/4. So if we add 2, so it's 3 and 3/4 and 3/8. So that's 6/8 plus 3/8, 9/8. So we're 1/8 over something. We're 1/8 over. Why not metric, for crying out loud? Why are you doing this to me? Right, so it's 3/4, so it's less than 1. So we're just over 3, just over 3. It's by my reckoning here, because we have 3/8, and then we have 6/8. It's 1/8 over 1/8 over 3 inches. That's my calculation. 1/8 over 3 inches. One eighth over 3 inches. be it there. That is supposedly 580. We will find out. Are you 580? No, not 580. So to make it 580, we're going to have to fool with that series one, and the series trimmer is first at the back, wasn't it? Series trimmer is second at the back. Second at the back. Take my, where'd my little guy go? Here we are. Second at the back. What am I trying to do here? I'm trying to bring in 580. Second at the back. What happened there? I heard a funny whoop sort of sound. We were doing so well, and then all of a sudden, okay, so let me change this. What happened here? Oscillator stop? I think the oscillator quit. We're at the low end of the AM band, and that's what happened last time. Now we're running it with 115 volts. How can I tell? I'd have to tune the radio up and bring it back down. Tune it up until I hear it come in. Check it with the SDR. Check it with any other radio. SDR is the best bet though. Okay, I'm going to get that going. We're going to just look and see if the local oscillator quit on it again. So we're tuned at 580, and that puts the local oscillator at 6.4, a little above a million. So we should see it a little above a million, about the middle of the display here. Middle of this display, somewhere in here. So I'm going to tune a bit and see if we can see it wiggling. I don't see it. Yeah, I don't think it's there. Got the pickup coil sitting right here. I don't think it's there. What was that? Now it popped in. Oh, I think it just popped in. Be right above my finger here. Oh, they shot it. Somebody shot it. The interference noise shot the radio. Don't need a local oscillator to hear that thing. Isn't that weird? That's just the weirdest thing. So there it is. Just, no, it's not quitting. Why didn't it quit? Like, why is it here this time? I was fooling around with this when it went away. Okay, so it was just under 3, just over 3. We're way off here. This is way off. So go down here. I can do this a different way, actually. I can actually measure the local oscillator frequency on the SDR and do it that way. So for instance, we have this at 580. So the local oscillator should be 455 above 580. That's because of my fantastic math mind here. So we'll go 580, and we'll add 455 to it, and we get 1035. So if you look on the SDR now, I'm going to full screen the SDR here, just a second. Okay, there's the SDR, and you can see the local oscillator is right around 1 million. It's that strong white line you see there. So we're actually pretty close. We should be. I was adjusting it. So the exact frequency it is, I'll put the SDR tuning indicator right on it. 10.5. And what did I say it should be? 1035. So I'll set the red line to 35. That's where we got to get this guy to move, this guy here, up to where the red line is. I don't even need the signal generator to do this. What I do need to do, though, is I do need to make sure I'm adjusting the right thing. It was the I can't remember. Okay, let me take a look. Oscillator series, second one at the back. Second one at the back. We also don't need to listen to it because I don't need to use the level meter. Second one at the back. Okay, you'll have to trust I'm doing this right. This is the one I was adjusting and everything went south. Okay, so there we go. I have the screwdriver in and we're adjusting. We're adjusting. Oh, where'd it go? Oh, that's weird. So it came back because I briefly shorted, I think, I shorted the screw to the chassis briefly, and it returned. I don't know what to make of that, but there it is. It's in the right spot now. Now we'll go back up to the other end and see if it's still where it should be up there. What a hassle with this radio. I should have marked these things instead of having to measure them every time. Okay. Nothing like complaining about yourself. Okay, where are we at here? I forgot what I was going to do. Just in the moment. What was I going to do? Huh, how you like that? Oh, go up to the top end and check it again. Yeah. Okay, let's go to the top end here. We're going to check it. Well, I'm losing it. Measurement for the top end. The top end is 520. It's the easy one. 6, 8 and 3/8. It's the easy one. 8 and 3/8 inches. Notice the string is laid flat here the whole time I've been doing this. It's working perfectly. 8 and 3/8. Maybe my neighbor's got a Model T or something in his driveway, in his garage. Okay, so that's now set. What frequency is it actually? Is it 1520 or who knows what? Very close. Very, very close. Now if I set this to 1520, how much more adjustment is required here? Nothing. Excellent. Good. Okay. So I declare the alignment done. And that could very well be the end of my work on this radio. The intermittent things that are going on, I'm not sure what to make of those. I think maybe the next stage, the next thing I'll do with this radio is simply play it through all the different bands and just listen to it and whatnot. And I'll do that on the next video. Next video will be a listen, see if it's really working well. So thanks a lot for watching, and it may be a couple days before I post the next video. So have a great time. See ya.